let's get started. This is today's last session, panel on P4. So we have 4 panelists. Could you please quickly introduce yourself, maybe starting with Dan?
Sure. My name is Dan Daly. I work for Intel. Well, yeah.
Patrick O'Sullivan, Goldman Sachs.
I'm Ben Pfaff from VMware.
Johan Tunzing, Netronome.
Okay, so thanks for joining the panel. I think you, as a group, represent a potential P4 user and potential P4 target providers. And we have software target provider, right, OVS, Ben, and then hardware target providers, Intel and Netronome. So I think this is a very good combination representing the P4 ecosystem to start with. So I have prepared a few questions, but this is an entirely open session, so feel free to join our discussion anytime. If you want to harass some of these people, feel free to join. And Bob unfortunately said that he's tired, so he won't be able to harass some of us, but please do so anytime. Okay, so let me ask one maybe initial questions, and then let's start from there. So I'd like to ask you this question. I mean, there must be some reason why you are participating in this P4 activity, and I presume that you wanted to solve some specific problems you currently have, or wanted to solve but couldn't solve easily so far. So which specific problems do you see and you wanted to solve using P4? Can anybody start with this?
That's an easy one. I didn't have a paper in SIGCOM yet. More seriously, with Open vSwitch, over time we keep adding more and more protocols, and people always want more, of course. And it's a bear to get them in. And if people can just write a simple P4 program, maybe a few hundred lines of code, and get that protocol in what they're working with, that's great. It'll make everything easier for everyone and make new protocols easier to deploy. I don't see any downside.
Great. Johan?
What our customers are really telling us is that the ability to add new protocols is very important, yes, and certainly they'd like the ability to bring them to market much more quickly than they can with traditional programming languages. But they're also saying that really customizing the behavior is also important and may actually occur at a more rapid rate than introducing new protocols. So the kind of behavior customizations people are talking about would be maybe responding to new threats and trying to protect against them, or there's a lot of monitoring going on, telemetry, these kinds of things to change the behavior of the data paths to help you with debugging the network, implementing more advanced quality of service, those kinds of things. So I think it's really both the new protocols and the unambiguous specification of behavior, but in a very flexible way that is the value. And if you think about SDN, software-defined networking, I would say that that's historically been a little bit of a misnomer, because it's really been software-defined network provisioning or something like that. And this way we can really have software-defined the network, the actual behavior of the network.
That's great. Did you want to chime in, Patrick or Dan?
Sure. So I think there's a lot of specific applications that we've thought of that, in a perfect world, things that we can implement. But broadly speaking, adding programmability into the network, in being able to do things with devices that perhaps the manufacturer or ASIC designer didn't think of, or really didn't see a marketplace for, but we have a use case for. That's really interesting. And the idea of taking some of these black boxes that are in the middle of our network, where we don't have a well-defined idea of what their forwarding behavior is, and opening them up shining the light on them, so to speak, as we start to see more P4 capable hardware come out. That can only make things better for us, particularly for testing and solving performance problems and monitoring problems.
Just to follow up with a simple question. So do you think it will be still useful if, say, fixed function devices still disclose their functionality at least in P4, even if it's not programmable?
Absolutely, because then, right now you have to rely on perhaps cryptic lists of, diagrams of how a pipeline works and a list of registers that you really don't understand what their functionality is. Saying that, describing something that exists already, is baked into the ASIC, there's no way to change in a way that now I'm learning to understand better. It just resolves a lot of the questions that we end up having when we talk to ASIC vendors, which is, what's this thing? It says this over here. Can you explain it in a little more detail? P4 will absolutely help in that regard if fixed function chip makers use it as well.
Great. Dan, did you want
Yeah, I just want to pick up on this
Yeah.
point about unambiguous specification. It can be used both ways, just like you said, is you could specify a fixed function pipeline, say this is exactly what I do, and it's a lot more concise than here's a 1,000-page spec on the fixed functions that I have. But the specification on the other side for a end user to say, this is the function that I want to do, and I tried to compile it on your box and it didn't work. It gives us a target to go and figure out how to make this implementable in the device that you've chosen in your network. So that it's a lot easier to exchange ideas and exchange requirements if we can write it down in a language that is a little bit easier than English and maybe a little bit less verbose than just handing each other C programs.
So it sounds to me, Patrick, like you at Goldman Sachs really go deep into the function of every device in your network. Do you think that's a common desire for end users? I'm curious.
I think it depends on the end user. I think we sit in an interesting place where, I alluded to this morning, that we don't have perhaps the resources or the commercial objectives to go say that we're going to do development into an SDK, for instance. But when you care about, for instance, performance and monitoring, some of those things, for observability, we are interested in chips. And I think there are other customers of our size that would be interested in those things as well. I can't say that 100% of the consumers of fixed function ASICs today, for instance, would be interested in that level of detail, but.
So, sorry to
go ahead,
hijack your.
please.
So, would it be fair to say that that one of the values of P4 then is that you don't have to learn 20 SDKs; you can just learn one notation?
Absolutely.
Great. I also have a minor follow-up question to you, Ben. Software switch is by default programmable already, but you're proposing a different kind of programmability using P4. So why does this different level of programmability matter to you and your customers?
Well, first of all, I have to acknowledge that I have a couple of different hats on here. One is as somebody who builds software that's used by VMware NSX, and there I'm interested in a pretty specific use case. But the other is that OVS is used by all kinds of people. If you go to Google Scholar, you'll find literally thousands of citations for it in papers and so on. And a lot of those people want to extend it in ways that are currently difficult. We get these questions on the mailing list saying, how do I add this field here? How do I add support for this thing there? And the answer right now is really pretty difficult. You have to not only know the problem domain that you're solving, in other words, what's the networking functionality that you want out of it. You have to know C really well. In addition, you probably have to know how to program in the Linux kernel, in DPDK. These days, maybe even in the Microsoft Windows kernel as well. it's a huge set of skills you have to get basically one little thing done. So OpenFlow to me was sort of the first generation of SDN. It let you program the protocols that were fixed, and with P4 you can first program the protocols, then you can program on top of them. I don't know whether that answered the question, but it's the way I feel about it.
So OVS is like a fixed function software.
Yeah,
it's kinda...
OVS is OpenFlow switch over a fixed set of functions.
Yeah.
Great. Okay, so if you have any questions, please feel free to join anytime. Tom?
Yes, so Patrick, you mentioned middle box, and I'm wondering, middle box is not just forwarding plane, right? It's layer, all the way to layer 4, layer 7, and all of that. So are you asking for P4 to support layer 1 all the way through layer 7?
So I just want to clarify what you're asking. In terms of parsing layer up to layer 7 information in a packet, or the desirability for control plane all the way to management plane to be opened up? Which?
Control plane all the way to manager, controlling it, defining what layer 1 should do, the layer 2, 3, 4, 5, 6, 7.
So, I mean, and I think Nick talked about this a little bit this morning, and the idea that the data plane has been something that's been very closed already today. So there's huge wins in being able to open it up. But I agree with you in the sense of, I agree with, I think, where the sentiment of your question is coming from, in that just having a data plane that can be, for instance, a load balancer doesn't solve all the problems of needing a load balancer. You still need a robust control plane on top of that to be able to program it effectively. But I think having a forwarding plane that is capable of doing some of these things enables someone like us to write some software on top of that perhaps we didn't have a good place to go program today. And that's where I think we can add some value.
But to add to that, I think historically, if you look at something like OpenFlow, there was the fast path behavior of a switch defined, and then you have packet in, packet out, and you can write software on the controller in some general purpose programming language, and those are your two choices. Now, the one is really fast, but all you get is match action tables, and the other one, very flexible. You can use Java or Python or whatever language you want, but everything runs on the controller, and there's nothing in between. What I think we really need to have here is not just have the protocol layering, but also a layering of the software, where we have the fast path, the medium speed path, the slightly slower speed path, etc. And some of them are in the server or switch in the same box. Maybe they don't need to run in the same hardware, so they could maybe run in a different type of processor or a different type of accelerator. And then all the way up to a hierarchy of controllers. And that way we can really solve the problem, similar to just how software is built. Nobody would actually say a function can call another function and maybe another function, and that's it. Software, you can layer any levels, any number of hierarchies you want. And we need to build our software in the network in a distributed fashion in the same way.
Great. Yes?
So we have a holding kind of workshop today. All the examples I saw about the functionalities, whatever target is, but they're all about the functionalities. So have we thought about how to resolve, the hardware is hardware, whatever it's chip or something else. But how we resolve the functionality via the scalability. So you can have, okay, I have a meter, but this hardware or this thing can only support 100 meters.
Mm-hmm.
So how do I know I want to do some 101 plus 100? How the P4 and how is it going to work? yes, you can define nice functionalities, perfect. What about scalability?
May I reinterpret your question this way? So you can describe your functionality in P4, but the actual amount of resources that are available on different targets may differ.
Right.
And the way they execute this at runtime, the performance characteristics may also differ. Right? So how should you how as an network applications owners, how should I try to adjust my level of sort of expectation as well as ensure the correct behavior across these different targets? Is that the question? Can any of you start to answer?
Yes, I can try. So I think historically, in the beginning of some of these standards bodies calls, there's always this disclaimer, you're not supposed to engage in anti-competitive behavior and this and that. And it's almost been like you shouldn't discuss pricing, but it's almost as if people treated performance and capacity as also an area that's kind of taboo. We're not allowed to talk about performance and capacity. But it's a very real problem that people want to know ahead of time when they even buy the equipment that they're going to have enough headroom there and that they're not just going to download something and suddenly it dies because there's not enough capacity or enough throughput. There's both sides, maybe even latency. So what I think we need to do is we need to have an unambiguous way of specifying what you expect. Similar to the behavior, you need to declare the performance that you expect and then some kind of a model of a device, what the device can offer, and try and match them up and try and find the right device when you make your purchasing decision. Or if you think about something like NAV and you're searching for a place to run your functionality, which of the instances of platform in the cloud can possibly run that functionality, to go and try and do that mapping. Now I think it's going to be very hard because I'm not aware of any general purpose software compiler that can predict a lot of these things other than by actually compiling and actually running, and maybe the out of memory condition only occurs when you're running. There's a bug, there's a memory leak. You only detect that later. But we should at least try to work on this modeling and predicting and characterization kind of aspect.
So I have a slightly different perspective. My understanding is that this has been a huge problem for OpenFlow implementations on hardware switches, that there's basically been no standardization, no way to really know what the controller can expect unless you pick a particular brand and model of switch. But OpenFlow from the beginning was a real compromise between the strengths of hardware and the strengths of software. And some of that hardware that we were trying to support was really very low end. But I suspect, I have optimism that P4 will be less of a problem because clearly there's a much higher minimum bar in terms of the hardware that you need to support it at all. It seems to me that it needs something that's much closer to a general purpose functionality. And so I'm hoping that P4 implementations will be much more closely clustered together in terms of what they can do.
I think as a network operator, I think Ben's comments were interesting because we had struggles with OpenFlow because of those compromises. But as a network operator, a great technology like P4 doesn't absolve anyone from being a responsible network operator. So, like, if you're designing a network, you need to know the parameters in which that network's operating and the underlying hardware. So I know that this particular chip has this many, exact match entries, this many LPM lookups. I know over here I have this router that if I put more than 4,000 multicast S-Gs in it, it's going to explode. Like, these are all things that we manage today. But the benefit of P4 is that we have the ability to use the resources more efficiently. So today, if you want to use resources on a chip differently, maybe you have to hit some register to put it in some particular memory mode. Now we can precisely define, we have a certain amount of resources, and we're going to use this one for this way and this other one for a different way. And as long as you're a responsible operator, you should be able to be more efficient and better use the resources that are there.
But we need to, P4 is going to continue to expand. So right now in the tables, you can say what size the table you need and things like that. They have that basic stuff, but it'd be nice to be able to say this table needs to run at X million packets per second, or this interface needs to have this bandwidth. It'd be nice to add that to the language, so that we can get rid of those. We can satisfy those sort of first order performance requirements that are in the system, and then we'll deal with all sorts of other problems, like in hardware, maybe your latency is great, but then once you have more than 1,000 entries in your table, the latency starts to not be as consistent, things like that. So we'll run into funny behavior that's not going to be specifiable. So, but at least we should expand the language to just do the basic requirements. So you can size the sort of the breadbox sizing of what your requirements are.
Great. Seems like there's another question there.
Christian from University of Campinas. We have heard about, so P4 was a high-level IR, and we have seen a number of backends, specific targets, like a number of backends are emerging, and there is also some work on it, on Vera, a lower intermediate representations, and I saw in some slides pointers to this lower IR. I would like to hear about the thoughts whether such a lower IR is necessary, will really emerge and be adopted, or whether a higher compiler backend per target would at the end be the practice. What are your thoughts?
I can start. So I think the HLIR is clearly able to support different targets. There are existence proofs for that. But one has to understand that the HLIR is more objects in memory. It's not a file-oriented IR. And there are some benefits to actually spitting out a file in a very clear format that other tools can then very easily absorb and work with, versus having objects in memory. And we can see that as the behavioral model V2, having created a JSON file, which is independent of the P4 language revision, but an actual file that you can go and process. So I think the open source SDN IR has that benefit, that it's actually a file that you can read in, visualize, transform to other files, etc., in different small tools. The other thing that the open source SDN IR tries to do is it tries to be less tied to P4. So it tries to be a little bit more language independent. Now today there are not a lot of different languages similar to P4 emerging. There was talk about Packet C and Flow C a while ago in the ONF, etc. But I think it's good to make provision for that emerging in future while we have the chance, because I don't really think it hurts you to have such a lower level IR that's a bit more language independent.
But how far are we from a multi-target IR? It seems like there's almost a different IR for every target at the moment. So do you feel like we're going to start converging soon, or?
Well, I think the open source SDN one is at least represented in that body is a number of different types of targets, and it tries to be multi-target, but also multi-language.
Right,
which
the
is
thin middle
key.
that we're all searching
Yeah.
for. Yeah.
Okay. Yeah, please.
What's the general consensus? Who is going to write the code? P4 code is
So I see a Cisco logo on the side of your shirt. So we'll be calling, just so you know, because we will break it. We break it today. I think that's a really good question. And I think we have goals of things that we would like to write in P4 that perhaps we don't expect to see show up otherwise in an open source community. Perhaps contracting folks to do things on our behalf if they're at a level of complexity it doesn't make sense for us to do. What I think is going to influence that is going to be how composability of P4 works out. And it's easy to see how if you take kind of orthogonal functions that you can take what the vendor's already shipped and then throw your own stuff on top of it. But what happens when you start to modify things that are not orthogonal? To me, that's a very interesting question and could get complicated, but could also be very powerful.
From metronome side, what kind of a general things you guys have seen from your customers? They're asking you to write the code, or they're trying to experiment with themselves, or it's too early in this process?
Yeah, so to clarify, Metronome's actually a silicon company, and we do have the NICs as well. So we're almost at the bottom part of the food chain there, and therefore the people that get our tools and write code could be anything from a box vendor to a data center owner and operator, kind of carriers, etc. And it could even be a tenant in a data center that rents a VM to run a VNF that also wants to write a little bit of fastpath code. So we see all of these things as potential scenarios. But I think even though P4 is a really easy to use language and very powerful, and that's why we're all here, because we're all enthusiasts, the reality is there's also a skills shortage out there, and probably there will be a whole body of consultants, as you said, that will emerge to specialize in writing this. The other unsolved problem is, fine, you can go and write the P4 code, but who's going to change Open Daylight, OpenStack, and all those things to go and work with that body of P4 code? So you almost will always need a group of people or an ecosystem of people that work together to address all of these layers.
That's why we're doing open sourcing, right? P4, a lot of P4 code will be open sourced, and then this integration, control plane management code, we expect them to be also open sourced.
From an OBS perspective, people already send us bug reports, whether it's our fault or their fault, and I'm prepared to own that for P4 too. It's part of the part of life for a software developer.
I have to say, Ben is the kindest mailing list responder I've ever seen.
I've matured over the years.
Okay, any more questions? So let me, because his question about performance and scale portability is such an important topic. So I just wanted, I know that as a moderator, I shouldn't chime in with my own opinion, but just to where P4 language consortium or P4 language design working groups co-chairs had right now, I just wanted to share one thing with you. So we are trying to come up with new standard architecture working group mainly to ensure portability or improve portability, at least across the devices and targets that are compliant to the standard architecture. And then we may actually choose to establish a few standard architecture, maybe one for switch, one for NIC, and maybe different types of switches as well. So the spectrum of this standard compliance can be a little broad, but still though, our goal is ensuring functionality portability. In my opinion, performance portability and scale portability, these are extremely hard problems. Even compute world haven't entirely solved this problem. Performance portability is not there even for compute, right? If you have a very application sensitive or performance sensitive applications, the only thing you can tell is that your machine has to have this many cores and you have to have this much RAM, right? scale portability is slightly different problem, and I totally agree with Patrick that this is not a new problem that P4 is creating. It's already there, but P4 at least seems to be making this problem a little easier to handle. So, any other questions? Well, if not, maybe I'd like to ask you one final question to the panelists as well as to the audience here at the floor. As a community, what should we do more and better? And also, imagine that you're going to come here, maybe not all of you, but a significant portion of you and maybe even more will come here next year at the P4 D2 day again. And some of you will have become advanced P4 programmers. Some of them may be new, but what do we want to see? What do you want to see at next year at similar kind of event? And what would be the success for that? Any suggestions or ideas, questions? Yeah.
As an operator, we like everything to be done as a single platter for us. And maybe have some kids, like high school or college kids, who give them some higher level of abstraction, that they can do some cool things with it and all of that. That would be really nice. That's where it will help us to get the higher level abstraction of these control functions and etc.
Mm-hmm.
Utilize for different programming.
More integration.
Yes.
Okay. Do you want to chime in? What do you want to do more through P4 language consortium?
I would just say, as a someone who's gotten interested in this stuff, I'd give myself kind of my own assignment of evangelizing a little bit, because it's very cool. I went through the first hands-on lab, and there's that moment when it works that you're really excited that hey, this thing works. And if you're like me, perhaps you don't have those cool moments as much as you may have in the past. So getting others to kind of be able to play with that sort of stuff, I think, is awesome. I think back to classes I had in school years ago where some of the things that are now super easy relatively with P4 was a ton of work to simulate network-wise 10 years ago or so. And making sure that, hey, a professor a grad student that is aware of what's going on in this community, was just going to expose it to more people and get more interest. So that's my homework, I would say.
Yes.
So I just wanted to chime in. So I think what would really help the P4 community, and I would love to see coming back at a subsequent workshop, would be more industrial commercial proof points that turn P4 from a backwater curiosity. A lot of our clients look at us and go, you're going to use P4 for that? Even just to specify behavior, and they think we're off in the weeds. So to come back in time and see successes, much like the Bing Catapult success was to show that FPGAs made sense in the data center, more and more P4 proof points in industry and in commerce would serve to enrich the community and say, this isn't some strange thing on the side, but this is something that really has traction, teeth, and value in industry.
I definitely agree. Yeah.
I'm hoping to find more time to spend on the P4 design work. I've been letting that slide a little bit, and I need to spend more time reviewing things and actually giving feedback.
It would be really helpful, especially with the new spec. Yeah. Yep.
I suppose if the P4 language can push down a little bit more into the HDL level, so that the developers can take that and do whatever FPGA, ASIC, and lower down the price. Because if you have a very specialized hardware to even capable of implementing, the market is not going to pick up.
Are you suggesting that we should invest in P4 to VHDL or Verilog compiler? Is that what you're saying?
Yeah.
I see.
Stand-up Verilog or stand-up
I see.
HDL.
Okay,
With
that's
certain
interesting.
architecture to partition between what can be, special, what can be, programmable, etc.
That's interesting.
I think there's a lot of good work going on in improving the language, and I think the next great challenge is the runtime interface. and doing the linkage to the control layers. But what would also be really helpful is to have comprehensive and real examples of what production programs might be like. I think we have too many toy programs, because having them just to test your implementation, to test your tools is useful, but also as a kind of a use case to drive the language evolution, the runtime interface evolution, etc., to make sure that we add all the right things that people will actually need in practice.
Along that line, P4 Language Consortium actually maintains switch.p4, which is the reference data plane implementation of L2, L3 protocols. Do you think that can be even further improved?
I think that's great as almost like one point in the space, but I think there's so many categories of devices people want to build with the language, and there's other use cases. Yeah. So we almost need, like, I'm making up stuff now, next generation firewall.p4 and load balancer.p4 and caching system.p4, etc. So we need those real-life applications that people...
Groundbreaking applications, not just repetition of the existing protocols.
Yes, and also not just forwarding, because many networking boxes do more intelligent things than just forwarding or just overlays. And if we have those, and we also have then the requirement on how they're controlled, that will drive the language for the fast path, but also the runtime interfaces we need to build.
Yeah, to start to focus on these killer apps that are popping up, like we mentioned, adding different headers and things like that to OVS. Why are they adding these headers to OVS? So we can understand why are these requirements coming from. I think a good application that popped up the last talk was the telemetry, INT. I consider that a killer app for monitoring your network. So as we talk about things that go beyond forwarding, sort of what's the killer app to have this type of programmability in different places, and maybe people will, better understand how to use that programmability as it sort of evolves. I feel like we're sort of at the crawl stage of crawl, walk, run, but sort of next time, the next conference, if we can talk about, this is the pantheon of applications that you can do now or in the future using these type of programmable pipelines. I think that'd be really cool.
I have to second the in-band network telemetry idea. I'm excited about the possibilities there too. But how do you feel about it? Is it something you want to use in your network?
In-band telemetry?
Yeah,
absolutely. I alluded to performance problems this morning in my talk, and I'm sure when I go look at my email again, there's going to be yet other mysterious issues happening in a production network that we have no ability to instrument outside of the kind of classical tools. And giving something that's closer into the data plane would literally give me more sleep.
I have a question about P4. So I understand that it's very experimental and it's still under development at this point. But is there some kind of a roadmap for this? Are we at a certain point now? Do we expect to be at a certain point next time, this year, for example? What kind of goals are set for P4 at this point?
So,
it's a good question.
Cheng, you're managing the...
Yes, I run the design working group, but this is a proper question for even Jen and Nick or maybe old people here. Yeah, we do have a few agenda and a few roadmaps. For example, earlier this year, I shared the roadmap for this year, and we're expecting to do this kind of things. If I may quickly recap that, we wanted to secure a new spec that introduces this concept of language architecture separation and more functionality, embracing functional heterogeneity and architectural heterogeneity so that the language can be useful not for switches but other types of devices, middle boxes and NICs as well. On top of that, we also wanted to come up with or define standard architecture. And then finally, runtime API auto-generation framework, because integration with control plane is very important. Just wanted to make sure that all the P4 compliant devices actually use the same API generation framework, right? So that we don't end up introducing a lot of islands there. So these are the top 3 goals, and then we're marching towards those goals on schedule. For example, the new spec is being worked on that Ben alluded. So that new spec will probably be available to you, be made available to you maybe in probably a quarter or so, including even implementations. And the compiler support will be there, and then auto-conversion tools will also be provided. So your P4 programs that you write today can be automatically translated to the next version language spec. So those are the activities that we're driving. But I also understand that more groundbreaking applications, those kind of aspects, integration with well-known control plane, software stack, and management stack, those things are also important. So we'll be constantly looking forward to build such an ecosystem.
I see. So the other impression I got today, and I could be totally wrong about this, was that the language is not 100% stable, because it seemed like some syntax has changed from the previous version of the release to this version of the release. So if now I were going to go and write a really, say, just for example, I was going to go and write a really complex application along the lines Johan described over here, what confidence would I have that on the next release of P4 everything's not just going to totally break and I'm not going to have to go and make fixes all over the place and invest even more time into this application? At what point would we feel like secure enough that it's stable now, I think I can go and write my app in this P4?
That is exactly the key goal that we want to meet with this new language spec. So we're going to say that, hey, this is, internally we are calling it V1.2, but officially probably Gordon and a few other people will tomorrow announce that we may actually call it P4 2016, following the conventions that other language community uses. And then that's going to be the stable base going forward. So all the upcoming changes starting that version will have to be backwards compatible. Otherwise, we won't introduce any new concept.
But you also mentioned earlier that there's a translator to automatically bring things forward from 1.0 to the one that's being worked on.
Yep.
Okay, so the translator is being currently worked on.
Yes.
All right. I don't have any more questions.
Great. So these are all great questions. I hope this event was useful for you. And then I really hope to see many of you tomorrow at the main workshop. Thank you very much. Thank you.
Yeah, on behalf of all the attendees, thanks to the organizers.